Welcome to another video. I'm going to be doing Gauss-Jordan elimination. It is just one step beyond just Gaussian elimination. And the reason is that when you're done with Gaussian elimination, you still have to do some algebra because you have to do substitution as if you were solving it using algebra. But if you're not supposed to do any algebra, just do arithmetic by adding and subtracting numbers, then you have to do the Gauss-Jordan elimination, which gives you your answer straight from just by looking at the last matrix in the set of operations that you perform. And some teachers would rather insist on Gauss-Jordan because they don't want you doing any substitution or subtraction or solving any equations using algebra. So it's just going to be purely linear algebra, which is matrices. Okay, so what is the advantage of doing this? Well, the last matrix clearly gives you your answer, which you don't get if you use just the Gaussian elimination, if you stop halfway. The disadvantage is that you have to do extra work. And sometimes this method of solving linear equations may not be the fastest, okay? And if you write a program to use Gauss-Jordan elimination, you might start having fractions and decimals, and then those decimals will get rounded up, and then you have what you call round-off error, or you just have some kind of error so that the final answer will not be exactly what you would get if you did it by hand. But we still have to do it. So let's get into it. So the first thing you want to do is, we don't care about x, y, z. You just want to write the coefficients of each of them, knowing that the things on this side represent x, everything in the middle represent y, everything on this side represents z. Okay, so we're going to transform this and write the augmented matrix. So we call it the augmented matrix. And that's going to be a matrix that looks like this. I'm going to write 3, minus 1, 1, and I'm going to write negative 4. 3, minus 1, 1, and I might do this, it's not necessary, and then I write negative 4. And then the next line is going to be 1, 1, 1, and then 2. 1, 1, 1, and then 2. And then I'm going to write 2, 3, 4, and then 8. 2, 3, 4, and then 8. Now, just looking at what we have, it looks cleaner than this, and easier to manipulate. And remember that this elimination sequence we're about to start, there's a main purpose. We're trying to want to make zeros here. So we're going to make this our first pivot, make these two terms zeros, make this our second pivot, make this a 0, and this doesn't have to be a 0. It just has to be a 1 at the end of the day. So remember that, okay, you may not know this, but the Gaussian elimination is what we call the row echelon form. Gauss-Jordan elimination, which is what we're doing, is the reduced row echelon form. Just understand that. And you probably saw the last video where we did reduced row echelon form when I was talking about the rank of a matrix. Yes, that's what we're going to do to this. Make it into a rank, and then you get your answer. So what can I do? Well, I need to make this a 0, make this a 0, but it's not easy to manipulate 3 to get rid of 1. They will start doing fractions, because if I want to get rid of this 1, then I'll have to first, it's going to be 1 minus 1/3 of this, and then you see fractions showing up. So your best bet is to have a 1 as the very first anchor. It makes your life easy. So the first move we're going to make is to swap these two rows. So I'm going to say that I am swapping row 1 with row 2. That's my first move, because I want to have this one sitting here. So this is what we have. If I swap, I'm going to have 1, 1, 1. Okay, now let's make our zeros. So I'm going to make these two zeros, and what will make this a 0 is if I get minus 3 of this and add it to this. Or if I get minus 2 of this and add it to this. So I'm going to say that row 2 is minus 2 of row 1 added to row 2. And row 3 is going to be minus 2. Sorry, this is minus 3. And this minus 2 of row 1 added to row 3. So we're going to keep 1, 1, 1, 2, 1, 1, 1, 2. And then this is going to be R2 minus 3 R1. That's easier for you to compute. R2 minus 3 of this, that gives you 0. And then this minus 3 of this is negative 4. And then 1 minus 3 is going to be negative 2. And then negative 4 minus 6 is going to be negative 10. Nice. So we go to the bottom one. It's going to be this row minus 2 of the first row. 2 minus 2 is 0. And then 3 minus 2 is 1. And 4 minus 2 is 2. And then you have 8 minus 4 is 4. Right there. So now what do we do next? Remember that we need to make a 0 here. But it is not easy for you to work with negative 4 when there's 1. So why don't you switch these two rows? So I'm going to switch row 2 with row 3. And this is what it's going to look like. Negative 10. That's what I have at the bottom now. Okay, so now I can make this a 0 by adding 4 of this to this. Let's see. So I add 4 of this to this. I'm going to say that the new row 3 is 4 of row 2 plus row 3. And what does that look like? It's going to look like this. I still have my 1, 1, 1, 2, 1, 1, 1, 2. And I have my 0, 1, 2, 4, 0, 1, 2, 4. But what I don't have anymore is this, because it's going to be 0. If I add 4 of this to this, it's going to be 0. If I add 4 of this to this, that's 6. And if I add 4 of this to this, 16 minus 10 is going to be 6. Ooh. So now this is where the Gaussian elimination process ends, because you've created everything and now you have an upper triangular matrix. Okay, so if you were doing Gaussian elimination, this is where you stop. You're just going to go here and conclude that. Remember that I said the last column is Z, the middle one is Y, and the first one is X. So you say 6Z equals 6. And then you get, and then see, you have to do this. 6Z equals 6, and then Z equals 1. Now, many teachers don't like you doing this because you're doing matrices. If you want to do algebra, you could as well just solve this using algebraic elimination. So they don't want you doing this, because if you get this, then you have to take one and go to the second line and say that because this is Y, it means Y, 1Y plus 2Z equals 4. And then you plug in 1 for Z, and then you get the answer. And when you're done, you go to the third one and solve another equation. We don't want to solve equations. We want to do matrices. So Gaussian elimination ends here. And then when you go a step further, it becomes Gauss-Jordan elimination. So now we're going to go a step further. Well, this looks like this, but I want all my anchors to be 1. Remember, it is the reduced row echelon form. So we want to make this 1, and we can easily do that by dividing this by 6. So if you do that, this is what you have. 1, 1. Okay, but we don't want to see, we want everybody to stand alone. This guy has to be alone, and this guy has to be alone, which means we have to get rid of this. Now, this is the trick. Once you get to this point, you want to start eliminating from the very last one. Eliminate everything on top of it so you can have your reduced row echelon form. So what do? Well, how do I get rid of this? I'm going to say that this row 2 will be equal to minus 2 of this added to row 2. And then I'm going to say this row 1 right here, leaving this, will be equal to the focus. Remember, it's this focus. So it's going to be minus row 3 plus row 1. Let's see what that looks like. This minus 2 of this gives us 0. So we still have our, oh, let's start from the one we're not changing. 0, 0, 1, 1. And then let's go to the middle. This is going to be 0. Well, this is a 0, so this stays as 1. And then minus 2 of this plus this gives us a 0. Minus 2 of this plus this gives us a 2. And then let's go to the top one. Well, there are zeros under this, so it stays. And we're dealing with this row and this row, so there's a 0 under. This one stays. Minus this plus this gives us 0. And then minus this plus this gives us a 1. That's what we have. We're almost there, because at this point, or just draw a straight line, okay? Sometimes that's better so that these dots don't confuse anybody. Make it straight lines. Okay, that just tells us that this would be our answers. Now, so what do? Oh, we don't want this here because this one has zeros. Only the reduced row echelon form just says that this one has to be the only one in that column. This has to be the only one in the column. So to get rid of this, we just subtract, or we add -1 of this to this, and that's it. That's the last step. So we're gonna say R1 is equal to negative R2 plus R1, and this is gonna be our final matrix. We're going to keep the bottom 0, 0, 1, 1. We're going to keep the middle 0, 1, 0, 2. And the top, we're adding negative of this to this. That's going to keep this as 1. Negative of this to this gives this as 0. Negative of this, sorry, negative this. It's negative this of this one. Negative 1 of this row to this. Negative 1 of this row to this is going to be 0. Negative 1 of this row, that's 0. And negative 1 of this added to this is -1. And you see the beauty of the Gauss-Jordan elimination? You don't need to explain anything. I know that z equals 1, y equals 2. So, therefore, x equals -1, y equals 2, and z equals 1. This is the solution to this system of equations using the Gauss-Jordan elimination. Never stop learning. Those who stop learning have stopped living. Bye-bye.